Hi, my name is Andrew McLaren, and I want to help you with diprotic and polyprotic acid problems. I've tutored a number of students on this, and oftentimes, I don't know how to start a problem when it's diprotic, or I get confused by diprotic, like the math involved in them. And they're kind of focusing on the wrong part, and it's very understandable because the math is tricky, but it's driven by the concepts situation. So when we're talking about diprotic acids, there's a few things that you really just need to keep in mind. When we're talking about them being diprotic, there's two hydrogens that are being donated, and that looks like two different plateaus on here. So there's like two different ideal buffer points, one for the first hydrogen being given off with the first Ka value, and some other second Ka value, which is representing a second dissociation or hydrogen being given off. These are two different steps that are done at two different points. And under almost all conditions, this second donation is not going to be significant. Only when you've added a lot of base will the pH be even relevant, where this second donation can come into play. In other words, the pKa is so high up there that you need to get something to be pretty basic to get the pH to be close to that, so that there can be any A2 minus present. And the Ka have anything in here where it's oh yeah, no, that that actually will act as an acid now. So to get the second donation to act as an acid, it has to be very, very basic conditions, aka you have to go past that second Ka value in the problem, and that's just not going to happen in most of the time. So usually X is insignificant in these problems. Thinking about that second donation, but not always. If you have very, very basic conditions, it might actually come into play being significant. But in this problem, they're just talking about the initial point of this acid dissociating and finding the pH. So that's kind of like X marks the spot here. So if we were to look at the Ka values, I just did the negative log of them to get as 5 and 9. And I just was looking at that, thinking through what that meant in terms of how big X should be. Knowing that hydrogen does have a little bit of, or Y has a little bit of hydrogen in it, this should be 10 to the negative 7, 0 conceptually. And that comes into play later on in the problem. Thinking about that, not as 0, but is that appropriate to think of that as 0, or is it maybe something else? So for this first Ka, we're able to think about it as just like a regular acid dissociation. This X is going to be essentially our final answer. It is worth thinking about the second donation possibly coming into play, but just thinking about the chart, the conditions are not very basic, so it's not going to give off much of A2 minus, if any, at all. So if you do the math, you'll end up seeing that the X being insignificant here would make this just really easy, and the X squared ends up being just your Ka value, which is a very small number. So we were safe in our assumption that A2 is present, but in such small numbers that it's not going to affect these final values. So if you were to take 10 to the negative 9 and try and plug it in here, you're still going to get 3.16 times 10 to the negative 3. It's insignificant. So us canceling that out is a safe assumption. It also is worth noting that this 10 to the negative 7 does not really affect the final concentration. That dissociation is far more significant than what would be present with normal water. But in the second dissociation, we also need to think about this hydrogen concentration in the initial. So it's good to pause there at first. Because you're going to need a pause here as well and think, is this significant or not? And what does that mean? In our context here, X is very unlikely to be significant, just knowing that this A2 dissociation is very small. So this like idea of like, is X significant or not, I'm guiding my steps through this chart thinking like, oh yeah, no, it's probably very small. So I'm going to assume that, do the math, and see if that actually is the case. And when I did that and canceled out what I got, I was like, oh yeah, if I plug that back in, it would be insignificant. Guess and check would always work as well. Thank you for McLearning with me. Before you go, please check out the following services that I offer with my business. So if you click the link in my videos, this goes to my website. I might be changing it from Podia because I'm no longer doing the interactive videos for sale. I might put those up for free. But most of my other services are linked here. So you can see that I've got like a Teachers Pay Teachers and a Wyzant. The Teachers Pay Teachers has a lot of my assessments that I have for like the NGSS, as well as lessons that I made when I was actually a teacher in the classroom. So I've got quite a few things like CERs and other things on there. If you want to get one-on-one live support from me, either like with science or like working on like teaching support lessons and that kind of stuff, you can sign up through Wyzant. I have a link to there where you can contact me there, and we can schedule hourly appointments. And I've got a few other things on here like a Facebook page, and other social media. And if you're interested in getting professional development with me for like a team of teachers, a whole page with information on that. So yeah, feel free to check that out. Thank you.